of the tangent line to y equals 3x squared plus 4 at x equals -2. So basically what this question would be asking is, well, we know that this is some quadratic function. 3x squared plus 4 is something like this. And we want to find the actual slope of the tangent line at -2. So we want to find the slope of that line. Well, we know that the derivative means the slope at a tangent line. So I can go ahead and just find the derivative. So I have like my power rule. The 2 comes down in front. 2 times 3 is 6. The new exponent is 1. The derivative of plus 4, 4 is a constant, so we know that its derivative is 0. So I can see that y prime is just equal to 6x. And so if I want to find the slope at -2, I can just find y prime of -2. Well, 6 times -2 is going to give you -12. So how can this be used? Like, that's basically what the next 2 units are about. But basically, I know that on this graph at -2, since the derivative is negative, that graph has to be decreasing, even if I didn't know what the graph looked like. And I also know that it would have to be decreasing pretty steeply if the slope of that graph, of the tangent line, excuse me, is -12. Today, though, we are going to just focus on like finding derivatives, because again, you can't really do the applications until you are comfortable with just finding derivatives. So I wanted to start off with this. Yes, on Friday, we did learn some derivatives and their rules. And I think it's helpful when you first start finding derivatives and learning these rules, is just kind of recognizing when you're able to find a derivative yet. So like in this first one, I have y is equal to x plus the sine of x. Is that a function that you would be able to find the derivative of using what you've learned so far? And the answer to that is yes. We know that when we're adding or subtracting, we can just take the derivative of each part. The derivative of x, that's a linear function. So the derivative of x is just 1. The derivative of sine is cosine. Again, there is no formula sheet on the AP exam. I know we're kind of working at home and virtual, but eventually you won't be able to look at a formula sheet. So you do want to make sure you start memorizing these as soon as you can. The second one, can we find the derivative of this one yet? This 2 right here is just a constant. So we know that we can start finding the derivative of this one. The derivative of this one, 2 is a constant coefficient, so it comes across. The derivative of sine would be the cosine of x. So those will be examples of ones that we can do right now in this class. This third one is an example that we can't do yet. Like, you're going to be able to do it in literally less than 5 minutes. This is not a constant. This one has a variable in front. So it's going to have its own rule. So that's going to be what we're going to be looking at today. And then this last one is going to be something that we can't do yet either. So like this third one, not yet. But this is what we're going to be looking at today. How will we take the derivative of that function? This last one, not yet. So we know the derivative of sine, but this is the sine of 2x. So we have kind of like this 2x trapped inside of the sine. And we won't be learning that one until like after the quiz. So we have a ways to go before we can even get to problems like that. Even though it doesn't look that complicated, we do need to kind of build ourselves up to that type of problem. So the rules that we're going to be adding, we have 2 rules we're looking at today. The first one is going to be called the product rule. So the product rule is going to be used whenever you're multiplying 2 things together with a variable in it. So the example I have for that is x to the 7th times the sine of x. So we have 2 things being multiplied together. They both have x in them. And the product rule for derivative states, you take one factor, and you're going to multiply it by the derivative of the other, and then you're going to add it to the second one times the derivative of the first. So basically, when you multiply 2 things together, the derivative is more complicated. You cannot just take the derivative of each part. You do have to follow the product rule. So if I'm taking the derivative of x to the 7th times the sine of x. What that derivative ends up looking like, so I have the first part times the derivative of the second. The derivative of sine is cosine, plus the second, which was sine, times the derivative of the first, which was 7x to the 6th power. So I kind of show you where things matched up. There's the x to the 7th. There's the derivative of it. Here is the sine of x, and then there was the derivative of sine of x. And it will always be plus sign in between when you're doing the product rule. There are ways to sometimes simplify it, like this one, mixing up trig and polynomials doesn't simplify that nicely, so I'm just going to leave my answer like that. And to be clear, a common mistake, the answer is not you just taking the derivative of each part. So you can't just say, oh, the derivative of x to the 7th is 7x to the 6th, and the derivative of sine is cosine. Like that would be very, very, very wrong. You have to use the product rule when multiplying things with x's together. Now we know sometimes in math, you can always multiply more than one thing together. So I don't always call this a separate rule, but it definitely helps you see a pattern. And it's called the extended product rule. So in this case, I have 3 things being multiplied together. And you basically just follow the process of the regular product rule. So you take the derivative of one piece at a time and kind of add them together. So like if I have maybe f times g times h, all of those have an x in it. The way to find the derivative is you're going to take the derivative of one piece, plus take the derivative of another piece, plus take the derivative of the third piece. So we would end up having 3 terms all added together. And notice I take the derivative of only one part at a time. So like when I'm looking at this example, I have an x squared, I have an x plus 2, and then I have a sine of x. So taking the derivative of this one, order doesn't really matter since we're always adding and multiplying, but I kind of work from the backwards to the front. So I have like x squared times x plus 2. The derivative of sine is cosine. And then plus x squared, now I'm taking the derivative of that middle piece. The derivative of x plus 2, well, the derivative of x is just 1, 2 is a constant, so it goes to 0. And then I want to take the derivative of that front piece. The derivative of x squared is 2x, and then I can leave everything else the same. To kind of color code it, so that x squared showed up twice and once as a derivative. The x plus 2 showed up twice, once as a derivative. And then sine of x showed up twice, once as a derivative. Questions on the product rule? So again, please don't ever just take the derivative of each part. Make sure you are expanding this using the product rule. And then the last rule that I'm going to cover today before we look at some examples is going to be the quotient rule. If there's a rule that students mess up, it tends to be the quotient rule because it is a little bit more complicated. And instead of like the product rule that has addition in it, the quotient rule does have subtraction, so the order does matter. So looking at this one, I have the derivative of f over g, and I'm just going to go ahead and write out the formula for you. And again, order does matter. So I have so that is the quotient rule. So we have like f is what's in the numerator, g is what's in the denominator. F prime is, of course, like the derivative of the numerator. G prime is the derivative of the denominator. And then when you see g squared, that literally means you're squaring the original denominator. Now, again, rules do have to be memorized. I'm I'm going to embarrass myself now, but it's okay because I do it every year. But back when I took AP Calculus, which was a long time ago at this point, the school year was 2005, 2006. Not a pandemic year, but lots of stuff going on anyways. My AP Calculus teacher taught me a song on how to memorize the quotient rule. So yes, I'm going to teach you the song as well. I will put a disclaimer that I have no singing voice at all. In fact, I sound absolutely like pure trash when I sing, so congrats to be able to listen to me on that. And again, like to this day, like I may not sing the song in my head, but I definitely like say it in my head whenever I do the quotient rule. I do think you do have to kind of understand the lyrics of kind of what it represents. So this is the song. It is to the tune of Old MacDonald, and I will sing it for you in a second. When I say low, I'm talking about the bottom part of the function. So low would be like the bottom part. High would be talking about the top part. And then when I say like D low or D high, we're saying that D basically represents the derivative. So before I sing it, I'm going to kind of write it out so you can see where the formula is coming from. So we have low D high less high D low. Draw the line, and down below, the bottom squared will go. So now I'm going to embarrass myself and sing it and use my bouncing pointer as I sing it. But I have low D high less high D low, da 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 da. Then draw the line, and down below the bottom square will go. And we're all in class, I'll make you sing that with me, but I'm not going to make us suffer through that right now. This will be recorded, so I guess you can play it as many times as you want to. But again, it's a cheesy song, it's silly, but like with that quotient rule, in that numerator, the order matters. Like if you flip-flopped those two terms in the numerator, like you're not going to have the correct derivative. So again, I don't always sing that song in my head, but I do definitely say the lyrics as I do the quotient rule. So to go back to this example, I have y is equal to x to the 7th over sine of x. Again, similar to the product rule, one thing you may not ever do is you cannot just take the derivative of each part. So like you can't just say 7x to the 6th over cosine of x. That would be really nice if you could, but math does not work out that way. We do need to do the quotient rule. So when I'm looking at this one, I have low D high less high D low, then draw the line, and down below, bottom squared will go. And that is the quotient rule. Do also be careful. Like some people just want to automatically start canceling things out in the quotient rule. Remember in math, you can't cancel across a plus or a minus sign. So it's often better just to leave the quotient rule as is, unless you're going to factor something out. So before I just look at a lot of examples, are there any questions on those two rules, I guess three, the product rule or the quotient rules, besides me singing again?
Mr. Brown, can you sing that again?
Yeah, no, next problem. So I did just teach you the quotient rule, but now I'm also going to tell you, hey, that quotient rule, as you saw, is pretty gross. So like if you can avoid the quotient rule, you can save time and be less likely to make a mistake if you can see a way to avoid it. Like it will always work, but you know that like you have to finish your test in a certain amount of time. The AP exam is time. So things that you can do more efficiently, usually you avoid the quotient rule. And what I mean by that, if I told you to find the derivative of y equals 5x over 6, a student who wasn't thinking, they're like, oh, that's the quotient rule. And they would just go ahead and jump in and be like, low D high less high D low, draw the line, and down below, the bottom squared will go, and then have to worry about simplifying that problem. What makes that problem a lot easier is you've just recognized, hey, I don't need to use the quotient rule because I can rethink about how I work out that problem. And 5x over 6 is the same thing as just saying 5/6 of x. And then that's just a linear function. Don't need to worry about the quotient rule. And since I don't need to worry about the quotient rule, I just know its derivative is 5/6, which is what this would simplify out to. Not that though. So you'll get the same answer if you use the quotient rule, but again, you can be a lot quicker and not use it. For example, in that second one, you could use the quotient rule. It's not the best way to do it. The best way to do that problem is to first rewrite it. So I can think of this as 2/3 x to the -4th, and then it's just the power rule. The power rule is a whole lot easier to do than the quotient rule. So like in that derivative, the -4 comes down in front, times 2/3 x, make sure you subtract 1, -5. So we have a derivative of -8/3 over x to the 5th. Again, you could do the quotient rule, but if you can avoid it, then it definitely makes your life a lot easier. Particularly if you're looking at this last example that I have on this page. This is one where if you did the quotient rule, it would work. Like it would be a really ugly derivative. In fact, I'm going to go ahead and find it using the quotient rule. So I have low d high less high d low. Draw the line, and down below the bottom squared will go. And then if I told you, hey, simplify that because it's a multiple choice question and you have choices A, B, C, or D, that's not a fun one to simplify. You have to like distribute twice, combine like terms, and then factor, and then cancel. That's the long way to do it. And again, you can do it that way, but if you do every problem written like that the long way, you're probably not going to finish what you need to. The shorter way to do this, and this one only works this way because we're dividing by a monomial, is you can first rewrite the function and then take the derivative. And what do I mean by rewrite the function? Since this is a monomial, I can split up kind of like what it was before they were added together, and that 5x squared can go to both terms in the numerator. Because one thing we'll see, the more simplified your function is, the more simplified your derivative is going to be. So by splitting it up that way, I can now say, all right, well, 10 divided by 5 is 2. X cubed over x squared is just x. 4 over 5 doesn't really reduce. X over x squared gives you x to the -1. And now you're happy. You don't have to worry about the quotient rule. So y prime is equal to, the derivative of 2x is 2. The -1 comes down in front, and the new exponent is -2. Believe it or not, that derivative is equivalent to that first one we did in blue. They are completely equal, but that one in green is definitely a lot easier to work with. Especially like units 3 and 4 of this class, basically the second half of the semester is all applications of the derivative. So like not only will you have to find them, but have to like do things with them. It's going to be a lot easier for you to do something with a derivative that is in nice, simplest form instead of that ugly form with the quotient rule. Again, you can't always avoid the quotient rule, but I do recommend if you can avoid it, definitely do avoid it because it does lead to a messy answer. Questions on any of that? All right, I'm going to stop with this slide today. We're going to do this slide and then I'll be done. So we have already found the derivatives of sine and cosine. Like we looked at those graphically and I said, hey, this is just a rule to memorize. The derivative of sine is cosine. The derivative of cosine is negative sine. Well, we can also find the derivatives of tangent and cotangent because now we know the derivatives of sine and cosine, and we now know the quotient rule. Why would I say we can use the quotient rule to find the derivative of tangent or cotangent? how can you rewrite tangent for that one? We'll say tangent first.
Sine over cosine.
Sine over cosine. So we know that this problem is really the same thing as saying the derivative of sine over cosine. Since it's the derivative of sine over cosine, they both have x's in them. We can use the quotient rule. So let's go ahead and find the derivative of that using the quotient rule. So I have sine over cosine, that's what tangent is. So I have low d high, the derivative of sine is cosine, less low d high less high d low. Remember, the derivative of cosine is negative sine. Draw my line, and down below, the bottom squared will go. So that is my derivative of tangent using the quotient rule. But it's not the most simplified version of that answer. We can kind of clean it up a bit. So like in this numerator, I have cosine times cosine, which we know is cosine squared. We have minus sine of x times a negative sine of x, which is positive sine of x squared, all over cosine squared of x. Some of you might see where this is headed. Does anyone see any ways that I can simplify that expression?
It equals to 1 on the numerator.
The numerator is equal to 1, so hopefully you remember your Pythagorean identities. You all made it out of pre-calculus, so I'm assuming that you do. We know that sine squared plus cosine squared, that is the same thing as saying 1. So this answer just becomes 1 over cosine squared of x. 1 over cosine squared of x, we can probably write that a different way as well. What would be equivalent of saying 1 over cosine squared?
Secant.
Secant squared. So the short answer to this is the derivative of tangent is secant squared of x. I show you that one so you can kind of see where it comes from. I do want to talk about some bad algebra I sometimes see. Some people, when they get to this step that I just put an asterisk by, they want to cancel out those cosine squareds, but again, you can't cancel across a plus or a minus sign. I like this problem because it reminds you that trig identities are a thing that exists, whether you like them or not. But it's also a way, like say you're taking the AP exam and you're asked to find the derivative of tangent and your mind goes blank. Well, the quotient rule you deal a lot more with, so you probably remember the quotient rule and you can figure it out. But I will say from now on, if I say find the derivative of tangent, you are allowed to skip all those steps and just memorize that the derivative of tangent is secant squared. To close out class, so I know I have, 10 minutes? Go ahead and see if you can find a formula for the derivative of cotangent, doing it the same way we did that problem. That will also just be a good review of you trying the quotient rule yourself. So again, I'll get you started. Cotangent is cosine over sine. Go ahead and take the derivative of cotangent using the quotient rule, and then see if you can simplify it to figure out a new rule for the derivative of cotangent. You have low d high less high d low. Draw the line, and down below, the bottom squared will go. So there's my work. So I have the derivative of cotangent. Cotangent is cosine over sine. So I have low d high less high d low. Remember, the derivative of cosine is negative sine. All over the bottom squared. Sine x squared is just sine squared of x. Sine times negative sine gives you negative sine squared, minus cosine times cosine, minus cosine squared. That almost looks like your Pythagorean identity. Not quite, but I can go ahead and factor out a negative 1. And then I do have sine squared plus cosine squared, which is 1. And so the derivative of cotangent is 1 over sine squared, which is the same thing as negative cosecant squared. Questions on my work for that problem?
No.
All right, so that's where I'm going to stop today's notes at. I do have just 2 more actual slides of notes to do. So we're going to look at the derivative of secant and cosecant tomorrow, and then along with just some general practice problems to do. Your homework that you can get started on is homework number 5. So I would finish homework 4 first. There's no point in moving on to homework 5 until you make sure you can master like the basic rules. So do homework 4 first. When again you see M4, that does mean multiples of 4. So tonight's homework that I'm assigning, again, there won't be any new homework assigned tomorrow night. It is the same kind of set on a different page. So 4 through 52, multiples of 4. So 4, 8, 12, 16, and so on. We'll finish up the product and quotient rules tomorrow. Wednesday is asynchronous, and then we'll finish up tangent lines on Thursday with your test a week from tomorrow. So at this point, if you're good to go, then you're welcome to go ahead and sign out of class. Today's notes were long. Tomorrow's notes will not be near as long, I promise. Enjoy the rest of your Monday. If you want to hang back and ask any questions, feel free.